Hello, my name is Maxwell, and welcome to this short video on understanding and learning math concepts. So first, let's think about what are math concepts. Math concepts or properties are essentially rules that govern what you can do within math. Knowing and understanding them gives you the tools to solve properly any math problem. So let's look at some examples together. The topics that will be covered in this video are solving equations, identities, and intercepts. So let's look at this first example. The example says solve the equation for y. So first off, we have to understand what is an equation. An equation in mathematics is kind of like a balance. So what happens, one side's equal to the other. So when we're trying to solve for y, we're basically trying to get y by itself. We're trying to isolate the y value. So how we do that is the first thing we do is we look at our equation 5x plus 3y equals to 24. Because we have a 3y on the left, we want to keep it there. So the first thing we do is we subtract both sides by 5x. So then what's left on the left side is 3y equals to, let's write the negative 5x first, plus 24. Now, we have 3y equals to negative 5x plus 24. Now we want to get just y by itself. To do that is because it's 3y, we get rid of the 3 by dividing. And what we do on one side of the equation, again, we'd have to do to the other. So on the left side, we're left with y equals to. On the right side, we're dividing each term by 3. So negative 5x divided by 3 stays as negative 5x over 3. And then 24 divided by 3, that gives us plus 8. So the solution is y equals to negative 5 over 3x plus 8. The next example says solve the equation for L. So applying the same processes that we did on the last example, we're solving for L here. So right now, if we look at our equation, says MP plus RL equals to T. Our goal is to isolate the L. So first thing we want to do is we want to bring that MP over to the right side. And we do that by subtracting it. What we do on one side, we do it to the other. Subtract MP both sides. So on the left here, we're left with RL equals to T minus MP. Okay, then the next step now is to get L by itself. We do that by getting rid of the R. We get rid of the R by dividing by R. And again, what we do on one side, we do it to the other. So what's left is L equals to, now we can write it a couple ways, but let's write it as T divided by R minus MP divided by R. So the solution is L equals to T over R minus MP over R. And that will be our answer. Now we need to determine if the equation is an identity. Now, first off, we have to understand what an identity is. An identity basically means that both sides are equal to each other. So either you can replace the left side with the right side or vice versa. So to look at this, we have x minus 3 times x minus 5 equals to x squared minus 8x plus 15. So we can determine if the left-right side is equal to the right side. Normally, you want to pick one side to work with and try to see if it's equal to the other. So on the left side here, we actually have two binomials because we have x minus 3 and we have x minus 5. We can actually multiply them by a process called foiling. Foiling is based off of the distribution property and it applies to binomials when you're trying to multiply binomials. So what FOIL stands for is F is first, O is outside, I is inside, and L is last. So when we're multiplying, we want to multiply the first terms together. So x times x. The outside is x times the negative 5. The inside is negative 3 times x. And the last is negative 3 times negative 5. So if we do that, what do we get? X times x gives us x squared. x times negative 5 gives us negative 5x. And then negative 3 times x gives us negative 3x. And negative 3 times negative 5 gives us a positive 15. So now what we can do is we say combine like terms. So we have a negative 5x and negative 3x. They can combine to get us a negative 8x minus 8x plus 15. So when we look, we notice that, oh, the left-hand side is now x squared minus 8x plus 15, which is equal to the right-hand side, which is x squared minus 8x plus 15. So that tells us that the equation is an identity, because we've shown that the left side is equal to the right side. Another example says determine if the equation is an identity again. But this time, if we look at our equation, the left side is a little bit different than it was in the last example. Now we have x squared minus 5x plus 3 times x plus 2. We can't officially apply the FOIL method as we mentioned earlier, because the FOIL method only applies when you're trying to multiply two binomials. However, you can still apply the distributive property to these two sets of parentheses. So how we do that is we can say x squared can be multiplied by x and can be multiplied by 2. The next one is negative 5x can be multiplied by x and by 2 again. And finally, the 3 can be multiplied by x and the 2. So if we distribute this, what we would get is x squared times x, applying the rules for exponents, we get x cubed. X squared times 2 is 2x squared. The next one is negative 5x times x is negative 5x squared. Negative 5x times 2 is negative 10x. And the last term is 3 times x is 3x. And 3 times 2 is 6. So now on the left here, we've combined like terms. We would get x cubed. 2x squared minus 5x squared is negative 3x squared. Minus 10x plus 3x is negative 7x plus 6. So that's our left-hand side, which is equal to our right-hand side. X cubed minus 3x squared minus 7x plus 6. So again, we've shown that the left side is equal to the right side. So the equation is an identity. Now this question says find the x and y intercepts of the following equation. So before we try to find the x and y intercepts, we need to understand how to graph this equation first. So our equation is y equals 7x plus 2. We should recognize that this is a linear equation. So if you look at the figure right here on the right, that's the graph of y equals 7x plus 2. So what are x and y intercepts? What they are basically points where the graph crosses the x and y axis respectively. So the x-intercept is the point where the graph crosses the x-axis, and the y-intercept is the point where the graph crosses the y-axis. So we can actually find this algebraically by, so let's do the x-intercept first. We can let y equals 0, and we solve for x. So that gives us 0 equals to 7x plus 2, because we replaced y with 0. So we're solving for x. So we do just like we did before. We get rid of the 2 by subtracting 2 both sides. So that gives us negative 2 equals 7x. And now we want to get x by itself, so we divide both sides by 7. So that tells us that x is equal to negative 2 over 7. Now vice versa, we do the same thing with the y-intercept, but we now let x be 0, and we solve for y. So that would give us y equals to, replace x with 0, so 7 times 0 plus 2. 7 times 0 is 0 plus 2 gives us y equals to 2. So the x-intercept written as a point will be, so we said that x is negative 2 over 7 and y is 0, and the y-intercept will be, so for the y-intercept we set x is 0 and y was 2, so order pair 0, 2. So that would be our x and y intercept respectively. This example follows the same thing. Find the x and y intercepts of the following equation. So as always, we want to identify what type of equation we're looking at. So because we have an x squared here, we know it's a quadratic equation. Particularly the graph of it looks like a parabola. Now for this one, just like before, the parabola, the graph helps us see where the x and y intercepts are. But again, we can do it algebraically, just like we did before, by letting the x-intercepts. To find the x-intercept, we let y be 0 and solve for x. So when we do that, we get x squared minus 2 equals 0. So we want to get x by itself. So first off is we want to add both sides by 2. That gives us x squared equals to 2. Now this time, to get x by itself, because we have an x squared, we need to take a square root both sides. So when we take a square root both sides, because the square is the opposite of the square, they cancel one another out. On the left side, we're left with just x. However, when you take a square root of a value, you always need to have plus or minus square root of 2. Because if you think about it, when you square a number, no matter if it's positive or negative, it will always give you a positive number. So square root of 2 squared or negative square root of 2 squared will always get you 2 regardless. So in this case, we actually have 2 x-intercepts, which actually lines up with our graph here, because we see we have a x-intercept on the left of the 0 and on the right of the 0 here as well. Now, do the y-intercept. So y-intercept is we let x equals 0 and solve for y. So here we would have 0 squared minus 2 equals to y, which then that tells us that 0 squared is 0, minus 2 is negative 2, so y would be negative 2. So the x-intercepts, this time we have plural, we have 2 intercepts, will be, so we can write it as one point is root 2, 0, and the other one is negative root 2, 0. And the y-intercept, we only have 1, will be 0, negative 2. So those are the x and y intercepts as points. Thank you for watching. If you need additional help with math, come visit us at the Math Homework Lab. We're located in room F234, and we operate as a walk-in, first-come, first-served basis. Thank you so much. This is some additional useful information when you're working on a project. And if you need help writing a paper, come visit the right place. We're located in G103. Thank you.